Hi, Gary Mrzinski back again, and we're going to continue with Chapter 7 of the Macroeconomy Today by Schiller and Gebhardt, published by McGraw-Hill. And we're going to take a closer look at how a price index is put together. And we're going to talk specifically about the Consumer Price Index. This is a price index that represents the overall level of prices of consumer goods and services. So if you recall the GDP equation, GDP equals C plus I plus G plus net exports. This is the C, the big C. It's measuring prices of those things, consumer goods and services. It's the price index that most often is used to measure the inflation rate. So in other words, the percent change in this price index from one year to the next is normally what's referred to as being the inflation rate, because that's the inflation rate of prices of consumer goods. Now, the way this is done is there is a hypothetical market basket of goods and services. And this is a collection of samples of goods that people buy and services that people pay for. And it's not every single good and every single service, but it is certain goods and services that are representative of all goods and services. And we'll show you in a second which types of goods and services those are. But the price index has a base year. That normally is the year that the price index was established. And the value of the price index in that base year is 100. So assuming that there is inflation happening every year subsequent to the establishment of the price index, then the price index would go up, because the price index is, again, representing the overall level of prices in a given year. So it should be larger than 100 every year after the base year, if there was inflation every year, and it should be smaller than 100 every year prior to the base year. The Bureau of Labor Statistics is the government agency that does this measuring of our price levels. They actually go out and measure prices across our economy. You'd be surprised how manual this process is. They tried to do this electronically, and it's just difficult to get the merchants who sell the products to participate and turn over all their pricing information digitally. So it's largely a manual process. People actually have jobs where they go shopping. Wouldn't that be great? Except they don't get to keep the products. They're just checking the prices. But still, this is what they do. And you can see this is done in 85 cities across the country, sort of representing all different kinds of areas and all different kinds of cities. You can see the numbers of stores. And they're also measuring the prices of, or the costs of, housing. So they also survey landlords to get that information. And here are the item weights for the Consumer Price Index in 2018. And as you can see, the largest category by far is housing. So this means that in 2018, the average household was spending 32.8% of their total monthly expenditure on housing costs. So this category includes the cost of the house itself, or rent if you're a renter. If you own your house, maintenance and repair costs are in there, insurance costs, insurance on the house, utilities costs, that's all included in housing. And the second largest category of expenditure for American households was transportation. So this is the cost of the car, and this is the fuel. So fuel prices are in there, insurance costs, maintenance and repair costs for automobiles. And the next largest category looks like food. That's self-explanatory. Insurance and pensions comes next. And healthcare is a large one. 8.1% of monthly expenditures were for healthcare. So they're given that weight. I have a question for you. How many of you are spending more than 5.3% of your disposable income on entertainment every month? I'll give you some time to ponder that. Now, when I was an undergraduate in college, this was probably 60% of my disposable income went to entertainment. But as you graduate, and many of you already have moved on in your lives, and you own a house, and you may have a family and children, and then your item weights begin to look like this pie chart. This is an interesting exercise which shows you the importance of the item weight, or the significance of it, to the consumer price index. If the price of any of these categories goes up or goes down, then the impact that it has on the consumer price index is dictated by the item weight. So for example, college tuition, and this is in 2018, had an item weight of 1.52%, which means that the average household was spending 1.52% of their disposable income on college tuition. Kind of an interesting and unusual product to choose, because for people that are actually purchasing college tuition, it's way more than 1.52%. But the vast majority of our population are not paying for college tuition in any given year. But the average ends up being 1.52%. 1.52% of all expenditures across our whole economy were on college tuition in 2018. Housing, 32.8%. So what if the cost of college tuition went up by 20%? What impact would that alone have on consumer price index? Well, it's 0.0152 times 20%, which gives you 0.3%. So 0.3% increase in consumer price index. And that's because even though that's a large increase in college tuition, the item weight is so small. Housing, on the other hand, that's the largest item weight in the whole algorithm. If housing costs went up by 20%, that would have a huge effect on CPI. It's 0.328 times 20%. It would make the consumer price index go up by 6.56%, just a change in that one category. And that would be, when you consider the rest of the consumer price index also, that would cause high inflation. Now, finding the actual price index is done this way. This market basket is assembled hypothetically, and then the prices are measured for the products that are in the basket. There's a total cost of the basket then that is established. And let's say in the base year it is $12,000. The next year it's measured again, and the composition of the market basket stays the same. Now, eventually it is changed, and there's a process for doing that, because we actually buy different things than we bought 10 years ago and 20 years ago. And in fact, some of the things we buy didn't even exist 20 years ago. Who was buying a tablet computer 20 years ago, right? And 20 years ago, people were buying VHS machines. You probably don't even know what that is. Well, they're not sold anymore. They were replaced by other products. So you do have to change the composition of what goes in that basket. But they're very careful about changing it, and then they make adjustments to the price index to account for that. For the most part, you keep the same products in the basket from one year to the next. So if in the next year the same products cost a total of $13,200, then this is how you compute the price index. You can see the equation that I have in the box at the bottom of this slide. So it's the ratio of the price indexes equaling the ratio of the prices of the market baskets. So the price index in the current year, which is what you're looking for, divided by the price index in the base year, well, we know that's 100, right? We already said that. It's always going to be 100 in the base year. That should be equal to the basket price in the current year, which we're being told is $13,200, divided by the basket price in the base year. That's $1,200. So again, in this formula in the box, it would be the price index that we're looking for divided by 100 equals 13,200 divided by 12,000. If you solve that for the current CPI, then you end up with a value of 110. That is the price index in the current year. And I tried to show that in those sub bullets, but because because of the way it appears on a slide straight across in linear form, it might not be as clear. But focus on the equation at the bottom of the slide in the box. That's the equation that I'm using. And I'm solving for the numerator on the left side of the equal sign. All right, so then that means the CPI in the second year is 110. The CPI in the base year, the previous year, was 100. What percent change in that CPI did we experience from the base year to the following year? Well, that was a 10% increase, right? When you go from 100 to 110, that's a 10% increase. That means the inflation rate was 10%. That's the way it's done. Here's kind of a neat example. The Consumer Price Index, this is an actual price index that we have values for, and you can look it up in a table. In 2006, the Consumer Price Index was about 200, and this is rounding it off. In 1983, so this was when it was established, the Consumer Price Index was 100. So let's call that the base year. So what does that say about a comparison of prices between 1983 and 2006? It means prices doubled, right, on average in our economy. If the price index doubled, that means overall level of prices doubled. The average price in the economy doubled between 1983 and 2006. Now going back in time, the Consumer Price Index in 1974 was about 50. So what does that say about a comparison of prices between 1974 and 1983? The price index went from 50 to 100. It doubled. That means prices doubled between 1974 and 1983. So what can you say then about prices in 1974 compared to prices in 2006? Well, they doubled by 1983 and then doubled again by 2006. So that means prices in 2006 were 4 times what they were in 1974. So now you're ready to answer this question in the last bullet. If a particular product was $10 in 1974, and if it was the average price product, what would that product cost in 2006? Or if you're to adjust for inflation, another way to look at it, what would that product's price be in 2006 dollars? Well, it's 4 times $10, $40, right? Some of what's in the market basket, some of those products, have more volatile prices than other products. And examples are energy. Energy can be volatile, and a lot of that has to do with the price of a barrel of oil, which can go up and go down. It's been fairly stable lately, but as that fluctuates, all energy prices fluctuate. And then the other one is agricultural products, food, because the conditions for growing any particular food product are very unpredictable. It depends on the weather, depends on the climate. It could be a poor growing season for, as we said earlier, oranges in the same year that it's a great growing season for apples in another part of the country because of weather differences and climate differences. And so that makes the price of food fluctuate. The other thing that makes the price of food fluctuate is because food, the cost of food, the prices of food, includes the cost to transport the food to the retail store where you're going to be buying it. And so as the price of oil fluctuates, that makes the price of food fluctuate too, to a certain degree. So we have what's called core inflation. That's where they change what's in that market basket. They actually remove the products that have the more volatile prices, such as food and energy prices. And so that's a more stable measure of inflation. But you have to realize then, if you're looking at just the core inflation rate, you're not looking at all prices, you're looking at prices of most products, but excluding the prices of food and energy. The Producer Price Index, before I explain this, let me explain that the Consumer Price Index represents the prices of big C in the GDP equation, right? So GDP equals C plus I plus G plus net exports. That big C are prices of end products, right? Final goods and services. GDP when we measure it that way, the expenditures approach, we're excluding the prices of intermediate goods and raw materials. Do you remember why that is? Because otherwise we would be double counting their value, because the value of intermediate goods is already reflected in prices of final goods. Well, if you are a producer of final goods, you are interested in what the prices of your resources are going to be. This is your resource costs. Those prices are measured too. Producer Price Index is one example of that. So if you are a producer, and this is broken down into all different categories of resources, such as agricultural products, all different types of agricultural products. So if you are a food manufacturer and you use corn, or you use maybe fruit products to produce your product, then you would be tracking that part of the Producer Price Index. Do you remember the Consumer Price Index is measuring prices of consumer goods and services? So in the GDP equation, that's the big C, C plus I plus G plus net exports. It's just measuring prices of C, consumer goods and services. The Consumer Price Index, therefore, would not be the best price index to use to convert nominal GDP to real GDP, because it's not measuring prices of everything that's in GDP. There are GDP price indexes. One of them is the GDP deflator, that's measuring prices of all of the goods and services that are included in GDP, not just consumer goods and services, but also investment goods, capital goods, plus government expenditures, everything that's included in that. And so this is a better price index to use to convert GDP values. The GDP deflator is the one that's in our textbook on page T-3 at the very end of your textbook. There's a table, and it's in the center column at the bottom. That's the GDP deflator. That's a price index that's good for converting GDP values. They actually do make more frequent changes and bigger changes to what goes in the market basket with the GDP deflator than they do with Consumer Price Index. And so it's not a good measure of pure inflation, but it still is the best price index to use to convert GDP dollars. Now it's time to compute an inflation rate. The inflation rate is just the percent change in the price index from one year to the next. So to find out the percent change, you remember the simple formula that we use, right? Any numbers that are collected over time, anything that's measured over time, it's the new number minus the old number divided by the old number. So then the CPI in 2006 minus the CPI in 2005 divided by the CPI in 2005 would give us the inflation rate for 2006. So let's see if you can complete this table. And this is a good time to maybe pause this video and see if you can figure out what these values are. So what you do is you're going to use the equation down below, and think of it this way. The CPIs that you see in this table, think of it as being the Consumer Price Index on the last day of the year of 2013, and that was 232.957. And the CPI on the last day of the year in 2012 was 229.594. So then the inflation rate in 2013 would be 232.957 minus 229.594 divided by 229.594. That would tell you all of the inflation that happened during 2013, and therefore that would be the inflation rate for 2013. So let's see if you can compute these inflation rates, and a few of them are worked out for you on the following slides. Here's one where you can check your work on the prior slide. The inflation rate for 2010, you can see we plug in CPI for 2010 minus CPI for 2009 divided by the CPI for 2009. And then multiply that by 100 if you want it to be a percent. And you can see it was 1.64. So that was a fairly low level of inflation in 2010. What is a good level of inflation that represents price stability? Typically, it's inflation that is less than 3%. So if it's 3%, we're not that worried about it. If it's 2%, that's even a little better. 4%, 5%, 6%, we start to get worried about it. So if it's less than 3%, it's a small, manageable level of inflation. That's the way to think of this. And so you'll see that our Federal Reserve, something we'll talk about later in this course, that's our central bank, they have a goal of keeping inflation under 3%. That's one of their goals. Now, there might be a trade-off between inflation and unemployment. This is explained further in Chapter 8, but I'll just quickly say that it works like this. If the unemployment rate gets too low, and we were getting close to that point just before the pandemic, it was under 4%. If the unemployment rate drops below 4%, it gets to the point where any increase in overall demand in our economy makes it difficult for sellers to be able to produce the products. Because to produce more products, you need to purchase or pay for more resources, right? You need to hire more workers if you're going to increase your output. But if those workers are already working and it's hard to find new workers because the unemployment rate is so low, at least the workers that you need, then the only thing you can do when there's increased demand for your product is to raise prices. So it is believed that if the unemployment rate gets too far below 4%, this will cause inflation and be a problem. So the government, again, this is going to be addressed later in this course, the government in a case like that will actually take action to slow economic growth, to slow overall demand for goods and services in our economy, to slow down the economy, to prevent inflation. Or if inflation is already happening, they'll do this. High inflation, I mean, like 4, 5, 6, 7%. Here are some values of the Consumer Price Index across time. And you can see in 2020, the Consumer Price Index was 258. The price index was established in 1982, 83, 84. So for those years, it has a value of 100. And then what they do is they get pricing information, the best they can find, going back in time, and they estimate what the Consumer Price Index would have been in prior years if it had been measured and computed in those years. So these are estimates, but it's the best we have to work with. And so what this means is prices today are about 2.5 times higher than they were in 1982, 83, 84, during that time frame. And let's go back further in time. In 1950, the Consumer Price Index is 24.1. That means that prices are 10 times what they were today as they were in 1950. And let's go to the very beginning of this timeline, 1800. So we were barely a country in 1800, and our economy was barely an economy. This is before the Industrial Revolution. So we were mostly an agricultural economy. We were importing lots of goods. We weren't manufacturing lots of goods. We were producing agricultural goods and a few other goods and exporting those and importing lots of goods. You can see the Consumer Price Index was 17. And then it came down as we started producing more of our own goods through the 1800s. And then 1875, the Civil War has ended. And then we're starting to become industrialized. And you see another decrease in 1900. And then, we start to see things become more normal after the Depression. So the Depression was in the 1930s. And from 1940 on or so, we speak of the post-World War II U.S. economy because that's, post-World War II is when things became more normal. The first half of the 1900s were not normal at all. We had 2 world wars, we had a depression, we had a bank collapse, we had lots going on, but things settled down after World War II ended. And same thing happened we had price stability, you could say, increases in prices, but more predictable increases in prices, and wages, more importantly, rose faster than prices over this period. Just another way of illustrating how prices have changed over time. This is the percent change in overall level of prices, consumer price index, percent change from year to year. That's normally what we consider to be the inflation rate. When you hear the term inflation rate, that normally means the percent change in the consumer price index from one year to the next. And you can see we are, most of the years within 0 to 4%, and you can see the periods of high inflation are when it is higher than 4% or so. And if you go back to the early 1900s, this is right before the Roaring 20s. We had lots of inflation, then we had deflation, then we had the Depression, we had some wars, and from 1950 on, again, that's the post-World War II U.S. economy, 1950 on, things kind of settled down, although we did have the big period of inflation in the 1970s, which was prompted by the oil shocks, and which we talk about in other parts of this course. But aside from the 1970s, things have been pretty steady in the 2 to 4% range most years. There are two causes of inflation: demand pull inflation and cost push inflation, that are explained better in the next chapter, because you're not really equipped to understand this once we have developed the aggregate supply and aggregate demand models. We can graphically show you how this works, and we will do that next chapter. But just quickly, two ways that inflation could happen: demand pull inflation. This again is the type of inflation I just mentioned. If there's an increase in overall demand in our economy for all goods and services, and everybody's already working, so there's no way to shift the supply curve to the right overall, then that's going to bid up the prices. It's going to pull prices up. The other way it could happen is cost push inflation. With cost push inflation, it's the supply curve that's affected. And remember what could shift the supply curve? The first thing we talked about was resource prices. If something happens to resource prices, if they get more expensive, then that's going to shift the supply curve in any given product market and in all product markets to the left, decrease in overall supply because it's more expensive to produce your product now. This happened in the 1970s. So the high inflation rates that you saw in the 1970s on that graph were caused by big increases in the price of oil. These were called supply shocks. They shocked the supply curve. And this was a point in time when we were much more of a manufacturing-based economy. And you use a lot more energy to produce manufactured goods than you use to produce services. Think about our largest services industry is financial services. How much energy do you consume producing banking services or insurance services or brokerage services? Not a lot, right? I mean, you just have computers in a high-rise building maybe, and that's not very energy consumptive. And but when you're producing automobiles, on the other hand, you're using a lot more energy per dollar of product produced. That's heavy manufacturing, right? Finally, two views on inflation. What should be our goal? Is zero inflation best? You might want to say it is, right? Because wouldn't it be great if prices didn't go up? Well, most economists believe that mild inflation is actually better than 0% inflation. Mild inflation meaning 1 to 3% inflation. There are a couple of reasons for this. Zero inflation is very close to deflation, too close for comfort. Remember all the problems there could be in your economy if you actually have deflation. This is where the value of the dollar or prices are actually going down. And so this would cause people to stop buying things if prices are going down. If you're going to buy an automobile, if you're in the market, you'd wait. Why would you buy today if the price is going to be less tomorrow, or a week from tomorrow, or or a month from now, or 6 months from now? So people stop buying things as prices are going down, and then stores stop stocking things. So dealers are not going to want to have many cars on the lot because they have to purchase them, keep them in inventory, and then sell them. Well, what they have in their inventories, they've already purchased at a certain price, and they're declining in value. They'd have to sell them for less money. That creates a problem. There's all kinds of problems with deflation. 0% inflation rate is too close to being, if you have that as your goal, then you might be 1% off plus or minus. So if you're off in the minus direction, you could have deflation, and as I said, that's too close. Now, mild inflation, if you have 1 to 3% inflation, think about this. This gives or makes available a tool for businesses to use, because if they can count on 2% inflation every year, that means that their price of their product is going up by 2% every year if they're the average company. That means their revenue is going up by 2% in an average year if they're the average company. What if they wanted to cut costs? Maybe demand is down a little bit, and they want to cut costs a little bit. And maybe they need to reduce their operating costs by 2% in a year. Well, one way to do that, if there's 0% inflation, would be to give everybody a 2% salary cut or wage cut. Well, that would not go over very well, would it, with the workforce? That would cause morale problems. People might start leaving the company. But let's do this instead. In the real economy, the U.S. economy anyway, we've had 2% inflation each year on average for a long period of time. Well, if you have 2% inflation, that means the price you're getting for your product goes up by 2%. Let's just freeze salaries for a year. People are not as upset about their nominal salaries being frozen, even when there's inflation, but that makes their real income go down by 2%, doesn't it? If there's 2% inflation and your nominal income stays the same from one year to the next, your purchasing power actually declines by 2%, doesn't it? So your real income goes down by 2%. This benefits the company because the price of their product that has gone up by 2%, but they managed to decrease the real cost of their wages by 2%. They don't have this tool in their tool belt if there's 0% inflation in the economy. Only if there is inflation. And again, you would want it to be mild. Anything more than 3%, when you get to 4, 5, 6, 7%, that's too much inflation. That causes instability in the economy. But 1, 2, 3% even is not that much of a problem. So that's it for Chapter 7. I'll see you in Chapter 8.